Yes, class. Good evening. Am I audible? Abdullah and Maha.
Yes, ma'am.
All right. Okay. So in the last class, we had done a very small portion and just a quick glance through of pulley problems. So that as soon as the problems will come, that we'll keep on discussing. But we had discussed it. So let's not do any numericals on that. Let's start with friction now. Now, friction is a very important topic for all of you. Friction in physics also it is important, as well as from your exam point of view also it is important. Before we start with frictions, let us just discuss frames. We have initial frame of reference is there. So frame of reference I have once discussed when we started with motion in a straight line. So since it's not been discussed with you people, let me just discuss it. See, frame of reference means place of observation. Frame of reference is simply place of observation. From where you are observing your system. If you are a passenger who is sitting within the train, for you the frame of reference will be within the train. So objects within the train will appear moving to you. But if your frame of reference is as that of a person who is standing on the stationary station, the person will see all the objects that are moving inside the train as moving. Only one thing can happen, no? Either the object can move or it can be static. But from one view, we are able to see that it is at rest. From other view, we are able to see that it is motion. So this means what? This is just because of place of observation. From one place of observation, you are able to observe a certain fact. From other place of observation, you are able to observe another fact. So this is just simply a frame of reference. Now you have inertial frame as well as non-inertial frame. Inertia we have discussed. So if the frame is at rest or in uniform motion with respect to the earth, then you say it is inertial motion. Then it is known as inertial motion. If your frame is at rest or it is in uniform motion. Inertial frame means frame at rest or in uniform motion with respect to earth are inertial. So these types of frames are what? These types of frames are inertial frames. These frames are inertial frames. So in inertial frame, the Newton's laws are valid. All the Newton's laws are valid in case of inertial frame. Here you will be able to use your Newton's law. Newton's law we have studied, all the three laws we have discussed it already. So Newton's law are valid in case of inertial frame. Newton's laws are valid. Now, if it is accelerating with respect to Earth, or the object or your frame is rotating with respect to Earth, then you say your frame of reference is non-inertial. Now you cannot use your Newton's law. Newton's laws are not valid in case of non-inertial frame. For non-inertial frame, you get a concept of pseudo force. As the questions will come, we'll see. Pseudo force is not actually a force. It's just a force that we add by ourselves to compensate and make the system in equilibrium. That we'll see. Pseudo force we'll see later on. But first understand initial frame and non-inertial frame. Inertial frame is what? Frame which is at rest or in motion, you can say. For example, a building is at rest with respect to earth. If you are observing it with respect to earth, then that building will be at rest. So it means now that becomes your inertial frame. And now in these situations, you are allowed to use all the three laws of Newton. And then we had what? We had non-inertial frame. So frames accelerating or rotating with respect to Earth. With respect to Earth, these are non-inertial. Frames accelerating or rotating with respect to Earth are non-inertial. Fine, these all are non-inertial. Now you cannot use your Newton's laws. Newton's laws are invalid. So here you get a concept of pseudo force. Pseudo force is not an actual force that is present. We make that force in a system. For example, a vehicle is there, that vehicle is moving with certain speed. Then to compensate the force that is coming forwards, we put a pseudo force in the backwards direction to compensate for it, because the frame is non-inertial. So these things you will see the application part with through the help of questions only. But telling the frames, understanding the frames is important. Please note down the frames clearly. Then we'll start with your static limit and kinetic friction. Fine. Friction is an important topic. And from here also, if you want to ask anything, you can ask. This, why am I discussing? Because this was discussed earlier when we had started the lessons, motion in straight line, and before that. So I think some of you missed it. So that's why I've repeated it once. Done. Maha and Abdullah.
Yes, sir.
Abdullah, you have also completed?
Yes, ma'am.
Okay. Now let's start with friction. So if you have any doubts, you can interrupt me in between because this is a very important topic. And any queries, you can ask me. See, friction, cause of friction, I'll tell you later. First, let's see. Frictional force you all are aware of. Frictional force is what? It's the opposing force. It is exactly in the direction opposite to that of motion. If this pen is gliding upwards, so frictional force will act downwards because it provides resistance to the motion. Provides resistance to the motion. It means if the motion is upwards, frictional force will act downwards. It just wants to oppose the motion. Now, there are certain advantages, there are certain disadvantages. Because if something is moving, moving. And to stop it, some force has to be there. So frictional force in this way is an advantageous force, because if frictional force will not exist in human nature, then what will happen? Objects will keep on moving. And we have already studied by Newton's law that unless and until you apply an external force, objects moving will not stop. They won't overcome their inertia. If they are in inertia of motion, they will remain in inertia of motion. Understood? So frictional force is necessary evil. Means it is necessary to provide friction at some places. It is necessary. But sometimes friction becomes a it's actually a dissipative force. Dissipative force. This is one of the disadvantages. So dissipative force, what happens? It means it produces loss of energy. You can observe this in fact. If you rub your palms together, both your hands together like this, then after a time, what will happen? The palms become hotter. The temperature in this palm rises. If you do this, you can observe this. What happens? Motion is there, rubbing is there. Frictional force will come exactly in the opposite direction to oppose it. So frictional force is, since it's a dissipative force, frictional force's action is doing its action, friction force is there. And since there's a loss of energy, then the potential energy or the kinetic energy, or you can simply say mechanical energy, gets converted into heat energy. And that's why we have the hands, whenever you rub your hands or any two surfaces you rub, they become hotter. This is the reason. So some advantages of friction are there, some disadvantages are there. That will be given to you as an assignment. From NCERT, you can read out. From net also, you can search. It's better if you read it from NCERT or the reference book, whichever you are preferring. Then what you can do, simply write down the assignment by that method. Okay, because this question comes for a few marks and it can come in your school exams. Now, starting with, there are types of friction. Static friction is there, limiting friction is there, and kinetic friction is there. Static, limiting, and kinetic. So static friction is there, limiting friction is there, and kinetic friction is there. Static and limiting are very, very close to each other. Actually, the maximum value you can say it is limiting. So both are very much related with each other, kinetic friction is. Now, let me give you an example. There's a block, a big block that I have kept. Fine. I have applied a force. A force exists in of the magnitude 1 Newton towards the right hand side. So if a block is there and if I apply a force 1 Newton, the object should move. But what I'm able to observe is it is not moving. So it means frictional force that is developed in the opposite direction is some magnitude greater. Fine. Or let's see, this is 1 Newton. This is also 1 Newton. So since frictional force is 1 Newton and the external force is 1 Newton, the object will not move. Both the forces will cancel each other. The object will remain in equilibrium. So this is 1 Newton. This is also 1 Newton. I have increased the force. Initially, I was pushing it slowly. Now I have increased a force a little more. This force that I've applied is 2 Newton. Fine. I am observing that the object is still not moving. So it means the frictional force that is developed over here, this is also 2 Newton. Till now, do you both agree with this fact that the body will stay in equilibrium? It will not move? Yes?
Yes, sir.
Yes? All right. Now, I have increased the force to a much greater value. I have increased the force. Let's say 3 Newton. Fine. I have increased the force to 3 Newton. This force that I have increased is 2 Newton. This is the applied force which I am referring to. Now what will happen? Now I am observing that this is moving. As soon as I've applied 3 Newton force, the object is moving. So frictional force value is still 2 Newton. Since the force on the right side has become more and the left side has become less, that's why the object is moving towards the right side. So frictional force 3 Newton exists and 2 Newton exists. As soon as the frictional force is increased to a greater value, even to 3.1 or something, let's say 10 Newton, object is continuously moving. Now see, this frictional force that was existing, this was what? This was your static friction. Static friction is the friction that acts on the body when the body has rest, and it is self-adjusting. It means if the applied force is 1 Newton, it will adjust itself to 1 Newton. If the applied force was 2 Newton to maintain the body in equilibrium, it will also have its magnitude as 2 Newton. So these forces that you were able to observe, this was the applied force. See, this side has applied force. And this side has frictional force. So static friction is what? Friction is the friction where actual motion has not started. If I am pushing something, let's say here I am pushing this. So I'm not able to move it. It means the static friction is existing right now. Since the object is not in motion, the object is static. From the term static only you can identify it. So static friction is what? It's the friction that acts on the body when the body is at rest. It's the friction that acts on the body at rest. And it means the actual motion has not started yet. Actual motion has not started yet, and it is one more point, it is self-adjusting. Self-adjusting means till the time static friction's maximum value is possible, it will keep on adjusting. If you apply the force, you increase the applied force, it will also increase its value to its maximum capacity. It will increase. Then a point will come that static friction will no longer be able to compensate and maintain the equilibrium. As soon as you apply a force just a little greater, let's say 2.01 Newton, you will see slight motion has begun. It means static friction's maximum value has now reached. So this maximum value of static friction is known as limiting friction. maximum value of static friction. This is known as limiting friction. Fine. So what had happened? Okay, let's discuss one more thing. Now, when the motion has begun, the object is moving. Object motion has now begun. This friction that will now come into existence once the body is now in motion. This is known as what? This is known as kinetic friction. So this acts when the body is actually sliding near another body, over another body. Fine. Like even if you rub your palms together, that the friction that is acting is kinetic. The bodies or the objects have to be in motion now. So it acts when the body is actually sliding, not near, over another body. It is always less than the limiting friction, because see, once the object has begun its motion, now the force that will act will be less. Initially, to change its state of inertia from rest to motion, we had to apply a larger force. Now once it has begun its motion, now the force that will be applied will be less. So that's why you have kinetic friction's value less than limiting friction's value. Fine. So remember this point as well in this. It is always less than limiting friction. Now let's quickly revise what we have studied right now. Through a help of a graph, let's study it. This is a graph between the frictional force. I'm depicting friction through small f and the applied force. Fine. See, when the body was at rest, what happened? You had started applying the force. Then there existed what? There existed static friction, because static friction comes into action whenever your body is at rest. And as soon as you keep on increasing the value of applied force, the value of frictional force increased simultaneously. And what type of force is this? This is static friction. So if you keep on increasing force, you'll keep on increasing, maximum value, it will get increased. After that, in which your static friction cannot increase its value. So static friction, to remain or maintain the body in equilibrium, the value of static friction force will adjust itself. It's a self-adjusting force. If applied force is 5 Newton, if it has the possibility to apply or adjust itself as 5 Newton, it will adjust itself as 5 Newton. Similarly, whatever force to its maximum value, it can adjust. Abdullah, you're asking something? Okay, he has lost his audio connection. Fine. Now a maximum value will come. Then there will be a very, very maximum value of this, from where you will be able to see just beginning of the motion. That friction, that is the maximum value of the static friction. That is your limiting friction. So initially it is increasing, and a maximum value has reached where the force cannot be increased. Fine. And then you will observe that the body has begun its motion and the value has also decreased. So you can see easily, this is what? This is static friction. This part is static friction, self-adjusting friction. And this part This is your limiting friction. Fine. And from here you have kinetic friction. Clear? Abdullah, you had lost your connection. Is it clear to you?
Yes, ma'am.
Clear? All right. We'll do all these frictions in detail also right now only. We'll see individual frictions. But before you just note it down, now let's see cause of friction. We have been studying friction exists, this type of friction exists, that type of friction exists, but there must be some cause for friction. And the cause is same that you have already studied from your earlier classes. See, an object is there, and the last layer of the object is also there. There are irregularities present in the surfaces. Even there are charged ions also present in the surfaces. You have both the oppositely charged ions as well. And the surface is also irregular. Both the surfaces are also irregular. So once these two objects come closer to each other or get interacted, both of these get attracted to each other. These two surfaces interlock among themselves. These two surfaces quickly interlock among themselves. And now they have interlocked. If this was the first surface, this was the other surface. This has been interlocked. So this provides a resistance in motion. Since due to the interlocking of these surfaces, intermolecular forces cause friction. So cause of friction is simple, intermolecular force between two surfaces, or you can say is this simply the cause of friction. Is the cause of friction. Fine. What had happened here? Interlocking of the two surfaces. It can be either just two simple irregular surfaces, or it can be ion surfaces where intermolecular force exists. Substances get locked with each other and you have frictional force coming into existence. Now, 3 points else you have to remember that are laws of limiting friction. Limiting friction we'll see right now only. After this, you can note it down and then we can see. But there are certain laws of limiting friction. Firstly, there's a normal reaction. Whenever you keep an object on the surface, a perpendicular force comes in reaction due to the gravitational force, as a reaction of gravitational force. If you keep an object, what is happening? Downwards gravity is acting, so gravitational force is acting. So how will the body will remain in equilibrium? If there is no force to counterbalance each other, the object should fall. Anyway, it should keep on falling. Anyway, it should keep on falling. But why does it not fall? Because normal reaction is there to maintain it. So frictional force, this point is very important. All the laws of friction are based on this. Friction depends on normal reaction. Wherever you are, whichever question you are solving of friction, even if you're forgetting, remember this point. Frictional force it will always depend upon the normal reaction. This is very important. And it is independent of area of contact. Friction can exist in this much surface also and in this much surface also. So this is independent of area of contact. And also you have to remember this, that as the roughness increase, how rough will the surface be? Smoothness decreases your friction. Lubrication, putting oil, that decreases the friction. But if there is a rougher area present, friction will be high over there because rough surfaces provide resistance. So friction increases with roughness. So 3 points you have to remember in this laws of limiting friction. Firstly, it depends upon normal reaction, that is the perpendicular force that comes into action. Then independent of the area of contact, whatever be the area of contact, it is independent to it. And the frictional force increases with the roughness. If your surface is highly rough, lots and lots of friction will come into exist. That's why whenever we play games sometimes, or whenever there's a stuck in your cycle chain, you put oil. Oil acts as a lubricant, it reduces the friction. So methods to reduce friction, and these 3 questions I have given you as an assignment that will be assigned to you. So these are certain points, very, very simple, easy points. I have repeated it also so many times. First, tell me, both of you, is the differences and the definitions of all three forces and types of friction clear?
Yes, ma'am.
Yes, ma'am.
All right. Then cause and definitely, if you've understood this portion, then cause and laws are very easy. Note this down. Now let's see the formulas for limiting friction. This was about the theory portion. Let's see the formula for limiting friction. Formula for all the frictions are simple. It's just the coefficient will change. If I talk about limiting, see static friction's value is exactly that of the applied force. So no need to calculate that. Limiting friction we can calculate. See, limiting friction, this is a body of mass m, gravitational force will act downwards, a normal reaction will act on it. Fine, please understand this normal reaction. Whenever, even if you are also standing on the ground, there will be a reactive force on it. Reaction will be exerted. Just a second. This is the normal reaction perpendicular to the plane surface. This is the plane surface. So frictional force will also be acting in the opposite direction. This is the limiting friction. So what did we study in the first law, in the laws of limiting friction? That frictional force's value is directly proportional to the normal reaction. So here also frictional force's value will be directly proportional to the normal reaction. And there will be a constant. If you replace the proportionality sign, you will put an equal to sign with a constant. The constant that you get over here, this is the coefficient of limiting friction. Just a coefficient, that's the ratio of friction and normal force. Friction is directly proportional to normal reaction. Normal reaction is a perpendicular reactive force that occurs whenever two surfaces are in contact. It is away from the body and it is perpendicular to the body. So friction force will be directly proportional to normal reaction. And if you remove the proportionality sign with an equal to, the constant will come. Here, this is what? This is your limiting friction. This is your limiting friction. This is what? This is your normal reaction. Normal reaction will always come whenever two surfaces are in contact. And this is coefficient of limiting friction. Limiting friction. Fine? Or even we can write this as maximum value of static friction. So coefficient of static friction will come here. But you can use limiting friction, static friction also. Both of the formulas you can use, meaning is same because both are pointing to the state of rest when the body is at state of rest. So this will be coefficient of static friction. Both are same. Please remember this, mu S and mu L both are same. Fine. For example, if I give you a question, let's say a body is there. Mass of the body is 10 kgs. And the coefficient of static friction is 0.3. We have to find out the limiting friction. This is the coefficient static friction we have to find out. See, how will we solve this? Firstly, gravitational force will act downwards. As I've told you, that is what? Mass into acceleration. And which acceleration will come now? Can you answer, Maha? Mass into which acceleration will come? If it is acting downwards, something is acting downwards, what type of gravitation will come? What type of acceleration will come? Yes, Maha.
Gravitational acceleration. Acceleration due to gravity.
Acceleration due to gravity. So this becomes acceleration due to gravity, and above there will be a normal reaction. Normal reaction's value and formula is not fixed, it just balances the other force. So now we can calculate the value of normal reaction. From here, you can easily say your normal reaction is what? normal reaction is equal to mg. This is equal to mg only. That is 10, and acceleration due to gravity is 9.8. Let's take 10 over here. So that makes it 100 Newton. And what did we study? The formula for frictional force. Right now we had studied. We have studied that it is mu n. So this becomes 0.3 into 100. That is 30 Newton. So this is your frictional force, 30 Newton. One more question, let's do. A body of 20 gram is placed on a rough surface. This is placed on a rough surface having mu s as 0.3. You have to calculate force of maximum static friction. See, if this is a case, if you are given this, then your body is there of 20 gram. Mg will act downwards, normal reaction will act upwards, normal reaction will be equal to mg. Now, mass, you cannot write it as 20 grams. You have to write it in SI unit. So this becomes 20 into 10 to the power minus 3. This is 20 kg now into 10. So that becomes 0.2 Newton. This is the normal reaction. Now, coefficient of static friction is 0.3. So coefficient here, coefficient is of static friction is 0.3. So frictional force is maximum value, that is your limiting friction, or the normal static friction will be mu s into n, that is 0.3 into 0.2, that is 0.06 Newton. This is your frictional forces value. So easy questions like this are given in the exam. Like this, one liner. You just have to see F is equal to mu n. Somehow you have to find out values of n. Once you get the values of normal reaction, then solving the questions become easier. Understood till here? Limiting friction is clear?
Yes.
Okay, noted down.
Ma'am,
Yes, Maha.
how did you get 10 raised to minus 3?
10 to the power minus 3 kilograms I've converted.
Oh,
One, see, 1 kg is 10 to the power 3 grams, 1000 grams. So 1 gram will be 10 to the power minus 3 kgs. So 20 grams will be 20 into 10 to the power minus 3 kgs. Got it?
yes.
So done. Written both of you or writing?
Right.
Okay, right. See, the last type of friction, that is kinetic friction, that the formula is easily predictable. In case of kinetic friction, just the difference that will arise is that the body is in motion. Otherwise, there is no difference as such in the formula. Kinetic friction. So your object will be there, mass m, let's say mg will be there, a frictional backward force, if kinetic will exist, normal reaction will there. Here also the formula will be mu k n. And if your normal reaction is equal to mg, then you use the formula F is equal to mu mg. But do not remember F is equal to mu mg. Many students remember it and get confused because every time the normal reaction will not be equal to mg. You have to focus on normal reaction, whatever is the value of normal reaction. For example, here also, if I give you a question, let's take an easy question again. A car is there, car's mass is 5 kg, the car is moving with a velocity of, let's say, 20 meter per second. A car is moving. Fine. Then the coefficient of kinetic friction that is given is, let's say, 0.4. And now we have to find out the friction force. Now see, everybody will get confused why the velocity has been mentioned. It means m into acceleration into something has to be calculated. No, the way you have been performing all your calculations, you have to do this calculation as well. Normal reaction upwards, downwards, mass into acceleration due to gravity. Normal reaction will be equal to 5 into 10, that is 50. So F will be equal to 0.4 into 50, that becomes 20 Newton. Got it? This is all your kinetic friction. One question where you will understand why am I emphasizing on not learning this normal reactions value. Question only. Let us do it in the form of question. This is a rough surface. A wall you can consider, a simple wall. Now, static frictions or limiting friction is given to you as 0.2. A force 20 Newton has been applied on this, and the mass is 3 kgs. Fine. Mass on no, let's take the mass as 30 kgs. Now, the mass gravitational force will act always downwards. This we have been studying from the starting. Acceleration due to gravity always acts downwards. So, acceleration due to gravity will come here, mass into gravity. But normal reaction, what did I tell you? Normal reaction is exactly perpendicular to the surface. So, perpendicular to the surface will give you this normal reaction. Now, see, can you tell me, is the normal reaction still equal to mg? Yes or no, according to you? Yes, Maha?
No.
No, definitely not. Because now your normal reaction is equal to this external force that has been applied. Normal reaction is equal to 20 Newton now. And mu s is 0.2. So your frictional force will now be 0.2 into 20. That is 4 Newton. Otherwise, it would have been 30 kg into 10, that is 300. 300 would have got multiplied by 0.2 to get the frictional force. But in this case, your normal reaction was not equal because the wall was like this, the object was sliding. So frictional force acted downwards, but this time the normal reaction is not down upwards. Normal reaction is towards the right. Normal reaction will always be perpendicular to the surface, no matter whatever is the direction of it. Fine. So these were your friction, types of friction, and the basics of friction. This formula is very easy. You have to remember, but calculation of this becomes important. Your normal reactions value. Okay, note it down. Just text me done when you have completed.